Hello, everybody. This is going to be a quick demo on how to build the Transcontinental Railroad in 6 years instead of 12. And so back in the 1860s, we decided they wanted to build a railroad from Omaha, Nebraska, all the way to the Pacific Ocean. They made it to Sacramento, which is close enough. They finished this up later. And so rather than having one team go and build this entire path in 12 years, what they did is they hired two different companies, one to build the Union Pacific Railroad from Omaha to what turned out to be where they met in the middle in Promontory, Utah. And another company to build from Sacramento heading east. And they both met up here in Utah, like I was saying. And it took them 6 years instead of 12, which is nice. If they had built the sequential program, it would have been just like build the, part from Omaha to Utah and then build from Utah to Sacramento. And then I could take a train from the beginning and end. And that's the goal, is to be able to do this, right? With being able to do things in parallel, you can imagine creating a fork in the road and hiring two companies like they did, one to build the Union Pacific, one to build the Central Pacific, and then critically join up in Promontory Summit in Utah, where they drove a gold spike in to commemorate everything. Then they pulled it right out because they didn't want anyone to take it. But then when that whole thing, when you're ensured that both of these sides are done, then and only then should we feel free to take a train from the beginning to the end. And so let's talk about how to build this program. I have here a quick sequential railroad construction. You can imagine creating 3 locations, one for Sacramento, one for Promontory Point, and one for Utah. Imagine creating 2 railroads, one from Omaha to Promontory and one from Sacramento to Promontory. And then what I'm going to do is use this gold spikes utility to combine the 2, where you pass in 2 railroads. It'll hunt through and look and see which are the common location, in this case, Promontory, Utah. And then, if it doesn't find any of those, it'll throw out a legal argument exception. Otherwise, it'll return you a new railroad, which goes from the beginning one to the extent of the other. And so this is, this is kind of nice. And then once I'm done with this whole sequential program, then I can take the train from the beginning to the end. If I run this program, I seem to have something by mistake. You can see the take train from beginning to end sits there and says, okay, let's print out that where I'm going from my beginning location to my end location, I'm going to go from Omaha to Sacramento. We're all happy. Let's see about how we can convert this over into a parallel program. And we're going to do it just like they did in 1863 through 1869, where we're going to start out with these 3 locations again. We're going to just build the Union Pacific Railroad as a future. Kind of like how the terminology works out here. Wasn't really intending it, but it's a future railroad, which makes some sense. We are going to leave this work behind. We're going to say fork, and fork in the road, and then we can do this in parallel. So what we're going to do is we're going to say, if anybody wants to pick up this work, you can imagine this is the company, the continuation is the company that builds the Central Pacific. Now I have this Union Pacific Railroad that is just a future. It's not actually the railroad. It's not completed. It's just a promise that will actually get done. The continuation will then move on after it leaves that work behind for the Union Pacific to be built, builds the Central Pacific Railroad. And then we get to the part where we meet at Promontory Point and we need this now, right? We need the railroad to be completed. Nicely, we have the join construct, so I can make a railroad that is the actual Union Pacific Railroad. Join of that future that we made a moment ago. Once again, now I can safely and confidently take a train from Omaha to Sacramento. And so hopefully that's a good example of how to build something in parallel. Certainly, they rightly chose to do it back in the 1860s. Nobody wants to wait around 12 years for a railroad to be completed when you can get it in 6. And so we do the same thing now with parallel programming.